All right, greetings everyone. Welcome to the second part of the video for section 7.4. Continue on with our study of this idea of changing midlines in a function. So I'm going to look now at writing equations for these types of functions from tables. And we're told here to find an equation of the form y equals a times sine of pi over 4t plus mt plus b, which here you'll notice that the midline is a linear midline and fits the data below. So inputs of t are 0, 2, 4, 6, outputs for y are 12, 15, 10, 5. And often these functions are hard to draw, but if we just try to sketch a quick kind of idea of what this might look like. So we're told that there's a point at 0, 12, and then 2, 15, so that would be above that, and then 4, 10, so that'd be kind of below that, and then 6, 5, so even further down. So it looks like we're kind of seeing a shape something like this, okay, which is, kind of hard to see what's going on. And so we need to use this to help us write our equation. Now, in order to do this, what I'm going to do first is I'm actually going to draw kind of a single sine wave, a single period of a sine wave that does not have a change in midline, so just something like this. And if you recall from earlier chapters, chapter 6 in particular, we can mark some important points here. So there's one there kind of at the origin, one here up above, one back on the midline, one kind of at a valley there, and another last back at the midline. And I kind of want to equate these points to the points that are given in the table, okay, or the ones from up above. Now, as I mark these, I want you to note that they're not going to be in the right spot. Like where I put 0, 12 will not be where a point 0, 12 would be, but they will equate to where they would be kind of within a period of sine. So for example, the first point, the one we start at, would be the 0, 12 right there. And then the 2, 15 would be the equivalent of the next peak. The 4, 10 would be the equivalent of the next point on the midline. And then the 6, 5 would be the equivalent of the problem, or the point down there on the valley. Okay, so I'll look something like this. Now, the reason we did this is to help us figure out which of these points we can use to find different things in the equation. Because I don't know about for you guys, but for me, it's hard to tell that from the picture up above. Okay, so what we're going to do first is start by finding the equation of the midline for this function, so that mt plus b form, which as we said is a linear midline. And so we know that when we have a linear function, the first thing we usually need to find is our slope. In order to find the slope, we need 2 points that are on the midline. Well, based on the picture we drew down here, looks like our 2 points on the midline would be 0, 10, and 4, 0, 12, and 4, 10. So we can use those to help us write the equation in the midline. Okay, so using our slope formula, we know we can write this as 10 minus 12 over 4 minus 0, which gives us negative 2 over 4, which equals negative 1/2 for our slope. And then to find the value for b, we could set up a linear equation and plug in a point in the slope and solve for b. Or we can recall that one way to think about the value for b is as the vertical intercept of a linear function. And notice we already actually have that information from right here, that point 0, 12 is the vertical intercept. So we know then that the value for b would be 12. So equation for our midline, or the part for our midline there, would be negative 1/2 for m, t plus the value for b, which is 12. Okay, and now we have our midline. And so we can put that into the function. So the function will now look like y equals a times sine of pi over 4t minus 1/2 t plus 12. And now we need to finish this by finding the value for A. Now recall that the value for A is the amplitude. So it tells us how far above or below the midline the function goes. So to find it, we should use a point now that is off the midline that kind of goes above or below the midline. So in this case, we can use the point 215. We could use the point 65. That would work too. Go ahead and plug that into our equation for x and y. So we'd have 15 equals a times sine of pi over 4 times 2 minus 1/2 times 2 plus 12. If we now work that out, we will have 15 equals a times sine pi over 4 by times 2. We can make that 2 or 2 over 1. So we get 2 pi over 4, which reduces to pi over 2. Minus 1/2 times 2, which gives us minus 1 plus 12. And then we would have 15 equals sine of pi over 2. If we think about our unit circle, that's equal to 1 times a will just give us a. And then over here, we have the minus 1 and the plus 12. Combine those two, it should give us plus 11. We can then solve by subtracting 11 from both sides. We would end up with a equals 4. All right. So now that we have the value for a, plug that in, write our final equation. Do it off to the side here. So in this case, we would have y equals 4 times sine of pi over 4t minus 1/2 t plus 12. And there would be our equation. All right. Cool. Let's take a look at another one like this. All right, so now we have to find an equation in the form y equals a times b to the x plus c times sine of pi over 2x that fits the data in the table below. And so this time we're working with an exponential midline. And we need to find the values for a, b, and c here. So what I'm going to do is I'm again going to draw the picture that I drew before, drawing a traditional single period of sine, maybe, if my stylus will cooperate. There we go. Okay, and again, we have those points. So this one here, 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 and here. And I equate them to the points given in the problem. So this first one here, that would be the first point, 0, 2. The next one here, that would be the point 1, 12. Oh my goodness. Oh Lord. Stylus does not like this corner of the computer. Okay, then we have 218 and 348. All right. So we again start by finding the equation, the midline. So we need to find the equation to a times b to the x, which we can start that by finding 2 points or using 2 of the points in the midline, which according to our picture here, looks like that'd be at 0, 2 and 218. If we recall the way that we solve or find the missing components of an exponential function, we set up equations using each of the points we have here. So in this case, we'd have 2 equals a times b to the 0. And then 18 equals a times b squared. So b to the 0 is 1, a times 1 is just a. Okay, and then now that we actually have the value for a, we can take that and plug it in for a in the other equation. So that would give us 18 equals 2 times b squared. You can divide by 2 on both sides, which would then give us 9 equals b squared. You can solve by taking the square root on each side, which in this case would give us b equals 3. And normally when we take a square root, we have two answers, right? A plus and a minus. However, you may also recall that the value for b in an exponential can never be negative, so we're only going to take the positive 3. Okay? So we got the value for a to be 2, the value for b to be 3. So that tells us then that our equation here, a times b to the x, would be 2 times 3 to the x. So right now then our equation looks like y equals, since we know this, to be 2 times 3 to the x plus c times sine of pi over 2x. We now need to find the value for c. But notice that's kind of in our place of a. The value we usually have is a, which means that's the amplitude. Which means to find that, we need to use one of the points that is off the midline that tells us what the amplitude is. So in this case, I'm going to use the point 112. And so when we plug that in, I have 12 equals 2 times 3 to the first plus c times sine of pi over 2 times 1, which is 12 equals 2 times 3 to the first. That would be 6 plus c times sine of pi over 2 times 1 is just pi over 2. 12 equals 6 plus sine of pi over 2 is just 1. Again, we get that from the unit circle, and c times 1 is just c. Subtract 6 from both sides, find out that c equals 6. And then we can plug that in back up here in our equation as our value for c. So that would be 6 there. And that would be our final answer then. So y equals 2 times 3 to the x plus 6 times sine of pi over 2x. Okay? Great, that's it for now. Thank you for watching.